Right, students, we're now looking at organic synthesis. So this topic is actually a combination of other topics, and it's all those mechanisms and reactions that we've been learning all year kind of rolled into one, and it's the idea of getting from reactant to product. Learning objectives for today, we need to be looking at properties and reactions of functional groups and constructing two-stage synthetic routes, so getting from point A to point B via intermediates. Here are some of the functional groups that we've seen already this year. We've got alkenes, alcohols, haloalkanes, aldehydes, ketones, and carboxylic acids. You need to be able to predict how they will react and also convert between those different compounds. So you need to be able to turn an alcohol into a ketone and vice versa. So give yourselves 2 minutes. I want you to just look at this and just think of all the different ways you could react this molecule. There's quite a lot, so discuss it with each other and write down your ideas. So you should have came up with some, hopefully. The alcohol group, we can oxidize that. We know we can. We can use potassium dichromate and we can turn it into a ketone. It won't turn into an acid because it is a secondary carbon. We could take the alkene and we could react that with a variety of different addition mechanisms. We could add bromine, we could make a dibromo. We could add iodine, make a diiodo compound. We could add water with a hydration reaction. We could add hydrogen bromide and make two different products potentially. We know about Markovnikov's rule. We know that you would get a major and a minor product. And finally, we can use the carboxylic acid. Now, we haven't really looked at what carboxylic acids do yet, and that's going to come up in this video. So our carboxylic acids are able to form polymers, or at least dimers, with another molecule via an esterification, where an ester bond is made. So let's look at this molecule, and we're looking at it again. We know it's got an alcohol, it's got an alkene, and we need to predict its solubility. We need to be able to predict its reactivity. So we know the alkene will react. We know it does addition reactions. We know the alcohol can react. We know that that does oxidation reactions. And we know that this is a mixture of OH, which is water-like, and that's polar, and a hydrocarbon, which is non-polar. So this will probably just about dissolve in water, but would also maybe dissolve partially in non-polar solvents. So there's a summary of that here. You can see the solubility being discussed, how the alkene could react. We could turn it into an alkane with a hydrogenation. We could turn it into a haloalkane with a halogenation, and we could turn it into an alcohol with a hydration with water. We know we can turn the alcohol into different things. In the previous video, we looked at how we could do a hydrolysis reaction, take off that OH and turn it into a halide bond. And we did oxidations, aldehyde and carboxylic acids, and alkenes is the dehydration using phosphoric acid. So this slide is a lot to take in, but this is the summary of almost every reaction that we've done this year. It has alkene chemistry, alcohol chemistry, haloalkane chemistry. It's got the potassium dichromate experiments in there, and it even tells you about refluxation and distillation. Now, those reactions as a whole are very complicated, but individually are quite straightforward, and you do know them. What I would like you to do is to create your own copy of this. So take some A3 paper or A4 if you want, and make sure you've got a copy of this somewhere. Do it in your own words, in your own writing, make it colourful if you want, but this is going to prove very useful when you're revising, because you should be able to just take any chemical that we've worked with and turn it into pretty much anything else. Using this flowchart, you should be able to get from an alkane to a ketone. in synthesis, we talk about target molecules, and it's basically an endpoint. Where do we want to be when we're finished? And usually two-stage synthesis is adequate, especially at A level. And what you need for that is to identify what you've got in your starting material, what you've got in your product, and how do you convert between those different parts. So if you have an alcohol in your starting material and you know that your product is an alkene, you know at some point you're going to have to do a dehydration reaction. I'm going to work through an example now, and it's how do I make propanal. I've got the starting material given of 1-chloropropane, and I've been asked to give equations for each stage. So the first thing I'm going to do is think, right, well, what does chloropropane have? What does that functional group do? How can I start the reactions off? We know that we've got to get from the starting molecule to the target molecule. There's going to be an intermediate step. And the only thing I can react on that starting molecule is that carbon-chlorine bond. I'm going to have to do something to that. And in the end, it's going to end up being an aldehyde. Now, I know that I can turn an alcohol into an aldehyde, but I don't know how to turn a halogen into an aldehyde. And that's because you can't do that in one step. You must go through the intermediate. So what can I turn a carbon-chlorine bond into that I can then oxidize to make an aldehyde? And the answer is an alcohol. So somehow I need to take this carbon-chlorine bond and replace that with an OH. Now in the previous video, we discussed haloalkane chemistry, which was a hydrolysis reaction where you would use the OH minus as a nucleophile, attack a delta positive carbon, kick off that chloride, and create the alcohol. So if I give you about 5 minutes now, I would like you to have a go at doing a two-stage synthesis to make butanone from but2-ene. I want you to show all skeletal formula throughout. I don't want to see any structural formulas, and I want you to provide any equations for each step. I want to make sure that those equations are balanced as well. So here we go, my two-stage synthesis. I've got my step 2 is creating the alcohol. And I'm going to do that using an acid catalyst like phosphoric acid and adding water. It will be gas state water, so I'm using steam, and that will give me my alcohol. Because the molecule is symmetrical, luckily there's no Markovnikov rule to worry about. My second step will be taking that alcohol, reacting with potassium dichromate and some sulfuric acid, and this time do it under reflux so I can fully oxidize, make sure I get what I want, and I'm going to turn that alcohol into a ketone. You may not be asked for the entire mechanism. You may be asked to predict reagents for individual steps. So here I've got 3 steps, but there are no reagents given. I have the synthetic route, but I don't have how you get from each step to the next. So on the left, I can see I have my alkene, and then after step 1, the alkene is gone. So what has happened in step 1? You need to be able to predict those reagents and those conditions. So if I give you another 5 minutes, have a go at figuring out what the conditions Hopefully you've managed that one as well. And the answers are going to be, for step 1, we've got hydrogen and a nickel catalyst to convert the alkene to the alkane. Step 2 will be sodium hydroxide to convert the haloalkane into the alcohol. You do that under reflux as well. And the final step is our potassium dichromate and our sulfuric acid to convert the secondary alcohol into a ketone. So to finish off, there are plenty of questions in the textbook, so help yourselves to a textbook. And page 243 and 244, there are a lot of questions for you to try, and they are all synthetic methods. They are all like this. They are getting from point A to point B and making sure you know every detail in between. So good luck with that. Make sure you've got them jotted down somewhere so I can have a look and mark them when I see you guys again.